Well, yes, folks. So, if anyone can tell me why this is appropriate, that would be good before it comes out. But yeah, it is school's out for summer, is what you're hearing the beginning of right now. So, in order to celebrate that, bring back yesterday's biscuit, because I didn't really talk about it properly. The double chop crunch cream, and I'm going to put it up just for a bit of last day entertainment up against the good old favourite milk chocolate digestive and see how it does there. Right, you'll be relieved to know that solving modulus problems, which is what we're doing today, is a bit of what we were doing yesterday, but it's not actually as tricky, I don't think, and it certainly shouldn't take us as long. So let's get cracking. So here's our first problem. So whilst you're copying that down, I'm going to have a little look at the first biscuit, the crunch cream, which is initially an almost ridiculously dry experience, but the cream really comes through. There's a lot more cream in there than you would have in like a, I don't know, something like a custard cream or something, and it's good and chocolatey, and that's going to take some beating. Right, so we're sketching the graph of the function. So the first thing to do is sketch y equals all of this stuff. Now in order to do that, we need to first of all think about what would y equals x minus 1 look like. So that, well, if we just start with y equals x minus 1, we know that that would have your y-intercept at -1, wouldn't it? And then a gradient of plus 1. So we've got that point there as being 1. We've got a straight line coming in there. But the reason I haven't continued it down below is because that's x minus 1, whereas we want the modulus of that. So that would be bouncing back up through here. So it's also going to, it's going to hit the both axes at 1, isn't it? 0, 1 and 1, 0. Moving on. We then need to do this bit outside the bracket here. So if we make another little sketch at this point, we know that everything is going to be tripled in terms of your result, so that's going to stretch it upwards, isn't it? The root's going to be the same, we're still going to be there, but instead of having a gradient of 1, it'll have a gradient of 3. Going up something like that, and that will be reflected, won't it? So that's going to go something like that, so that'll be at 3, and then the whole thing is -2. Now the modulus bit has happened, so this is after it, so we can have negative in here. So my final sketch is going to need -2 in there, because that whole thing is being pulled down by 2, so the 3 comes back down to the 1 again. Hang on, I've gone in the wrong place there, haven't I? Yeah, that should be just there, and my gradient is 3, so I'm going along 1 and at 3 before sketching that. And that is, if, oh, and it says t, doesn't it, in there, so I should have t on my axis there, so that is the t of x is equal to 3x minus 1 take 2. So that's the graph done. Now it says state the range of the function. So the range is what we're getting as our y's or t's in this case, isn't it? So what possible values are we getting? Well, the smallest possible is -2, and then it's just going up and up and up, isn't it? So we can say that the range is t is always going to be bigger than or equal to -2. So that's part B and that's part A. And the final thing to think about is solve the equation where our function is going to be equal to 1/2x plus 3. Have a little think about that whilst I try out the digestive. And I'm afraid that really did suffer for being eaten immediately after the other biscuit. It tastes really sickly in comparison. Quite similar in other ways, but yeah, obviously a nice biscuit, but I wouldn't have it after a crunch cream if I were you. I did that the wrong way round. So I've got my sketch here. I don't have to sketch it to solve this, but just so that you know how many solutions you're going to get, I think sketching is a very good idea. So y equals 1/2 or t equals 1/2x plus 3 would be going through the y-intercept would be at 3, wouldn't it? And then the gradient is 1/2, so along 2 and up 1. So that means it's going to give us something. Have I got any kind of ruler around here? This will have to do. It's going to be going in something like that, isn't it? So we know I'm going to have one small negative solution, one small positive, and actually because I've done it in squares, if I thought about it, I could probably work it out exactly just from the graph, but we do need to be able to do this with an equation. So all we've got to do is write that we're going to have our original function equaling 1/2x plus 3. It's going to give us two solutions. And how do we deal with this again? We've got to deal with it when x is a positive value and when x is negative. So we're going to do that. If we do the positive one first of all, so expanding this bracket's going to give me 3x take 3, and then I've got that take 2 there, haven't I? Now all of this needs cleaning up. I've got, that makes -5, so if I add 5 to both sides and I take 1/2x, I'm going to add 5 to both sides, I'm going to take 1/2x, and that'll give me 2.5 left, which we'd normally call 5x over 2, wouldn't we? And if I add 5 to this side, I get 8. So then if I double both sides, I get 5x is 16, and therefore divide by 5, my x is going to be 16 over 5, or 3 1/5 if you prefer. So that's when it's positive. Does that make sense? 3 1/5. Yeah, it looks like it could do, doesn't it? Yeah, it could be about right. And then we're going to do it for if it's negative as well. Let's have a quick go at that. So you're starting with an equation. Sorry, I'll stop messing around with that. Right, look at that. So we're timesing the negative bracket by that, or you can put the negative in front, doesn't make any difference. Negative 3x plus 3 when you multiply negative by a positive, and then we're taking 2 is all the same thing again. And if we clean that up this time, I'm just going to sort that out to be 1. I'm going to add my 3x over here, which means I'm going to get 3.5x, or 7 over 2x plus 3. Take the 3 across, and I'm going to get -2 is equal to 7 over 2x, so times it all by 2, and we get 7x is going to be equal to minus 4 divided by 7, and x will be negative 4/7. So we've got our two solutions being there and there. Right, so here's our last example then. There will be one or two more questions coming in a minute, but first of all, given the function there, now that could be saying that sometimes that's just another way of writing. Okay, so we can get that, can't we? So that means the same thing. So the first thing is they've done a sketch of this here, just showing us the roots, and we don't know what the y-axis is for there. We could work it out there, and in fact we're going to need to, because the first thing it's asking is state the range of f. Well, you've got 6 here, and you're going to be taking away 2 times whatever the modulus of this is. So the smallest amount we could be taking away from it would be 0, because this is a modulus. We can't be having a negative, so it's got to be a positive, so we're going to be taking something away, unless we're taking nothing away, because if x was negative 3, oh, that looks about right, doesn't it? If x was negative 3, this, like a bracket, would be worth 0, and 2 times 0 is 0, so we'd be taking 0 away. So the highest possible value that we could get for our function, our highest possible value of y, would be 6. So the range of f is going to be y is not bigger than, smaller than, or equal to 6. Okay, right, now part B wants to know, what does it want to know? Okay, it wants us to give a reason why f minus 1 does not exist. Now, what does that mean? That means the inverse function, doesn't it? So why does the inverse function not exist? And this comes back to, well, what is the inverse? It's when you reverse something, isn't it? Now, if I reverse whatever process, I've got 2 ways here of getting 0, haven't I? So if I end up with 0, how, when I reverse that, am I going to get both results? There's no way of having one process that's going to take me to 2 places. So that's why you can't have it, and that's called a because this one is a many to one function, because we've got two inputs getting one output, then that's why we can't reverse that. So it's because the function is a many to one function, and that's all we need to therefore all we need to write. I mean, strictly speaking, we're meant to say therefore does not exist, but that's pretty obvious. You should get away with that if you forgot it, but it's always good to make sure of these things. And we've got one more tiny little thing to do. Well, I say tiny, but, and we're going to be solving an inequality here, folks. So we're going to be solving our function being larger than 5. So have a little think about that. And the first thing to consider is, well, when is it going to be larger than 5? Well, if that's 6 there, 5 is going to be about there, isn't it? And if I was to draw this across here, there is the line y equals 5. It's only going to be bigger than 5 within that little region there, isn't it? So we need to solve 6 minus 2 is equal to 5 in essence, and then we know we're going between those two bits, don't we? So the first thing I'm going to do is I'm going to do the what it would be for the positive value of x first of all. So 6 minus, so I'm just going to say that I've got that. Expand the bracket. Should give me that. I've got negative x, so if I add my x's over to that side, 6 minus 6 is nothing. Take the 5 over to that side, I'm going to have minus 5 is equal to 2x if I take 5 and I add 2x, and those two cancel themselves out. Therefore, we can say that x is going to be minus 5 over 2, or minus 2.5. So that's the one when it's your positive value on there. Then if we do the same thing for if the bracket is negative, expanding this bracket, I'm going to have negative 2 times negative x is going to give me plus 2x. Negative 2 times negative 3 is going to give me plus 6 is equal to 5. 6 add 6 is 12, isn't it? So I'm going to get 2x is 5 take 12, both sides is negative 7, divide by 2, and therefore we get x is negative 7 over 2. So that means we're talking about negative 3.5 and negative 2.5. Does that look like it makes sense? Well, I'm expecting the peak of that to be at 3, negative 3, and we're either side of that, so that all looks very good to me. And we just need to give our final solutions, because it's an inequality. The bit where it's bigger than 5 is going to be when your x value is bigger than the smaller value. So which one's that? So that one's my smaller value. So when it's bigger than that one, and when it's smaller than the other. And that's our final solution. Now, in terms of practicing these, we're going to do something similar to what we did yesterday, because page 51, exercise 2G, the first question again has got quite a lot of nice little practice of 4 of these different functions for you to have a go at. And then if we do one exam style question later on, which has got a bit of problem solving in it as well, make that question 9, and they'll be coming up on here to follow. And that just about has us all the way done. So